welcome everyone. I appreciate you jumping on yet another video conference during this strange work from home period. Definitely acknowledge that our thoughts are with each of you and your families. I hope that you're all healthy and well, and we know that, like all of us, your situations have changed, and your personal lives and your work lives have been really significantly affected as our country is dealing with the COVID-19 crisis. And today's seminar, we're going to address some of the impact of the virus, not so much on health, but on what it means for operating businesses, particularly in the industrial sector. We want to talk about how the changes that we're experiencing are affecting the new normal during the lockdown, and then looking ahead post-lockdown to a time where we're returning to work, but when things might still continue to be different. So hopefully this will result in some thoughts and ideas that will be helpful, and will give you some view of how Everactive sees that technology can help to solve the problem. So I thought I'd start with some things that I've really thought through a good bit as we've been dealing with the COVID-19 crisis, in terms of how different impacts and results of the crisis have caused us to change the way that we operate, the way we function at work. So first of all, of course, lockdowns and social distancing and work from home protocols have meant that we have fewer workers available on site, maybe no workers on site, and certainly a reduced amount of access to a site. And in an industrial setting, that site has all of your assets, and the factory, manufacturing plant, or the physical assets that allow the site to do the work that it needs to do. When you have fewer workers on that site, of course, you're less capable to intervene. We also, with more people working from home, I know I'm dealing with things like childcare and taking care of family issues, and have less time to work even from home, and certainly less time to go intervene back at a site if we need to go back into the physical spaces where we used to work. So companies in general and teams are less capable of intervening when there's a problem. As an obvious implication of not being on site, we have less information. It's sort of disconcerting to realize that nobody's been into an office for a number of days, and that the pipes could be leaking or something could have gone wrong. We don't know what's wrong. And when something is going wrong, it's hard to know what to do when there's not enough information available. Our teams are also, of course, trying to make up for being remote by using tools like Zoom, but it's certainly a lot more difficult to interact. And that couples with the reduction of information and makes it even harder to know what to do in the case of a crisis, or in the case of something that requires intervention. And of course, for most businesses, this time is unfortunately resulting in a loss of revenue, which means that for industrial plants, uptime is even more critical than it was before. Of course, it's always critical to have no downtime, or as little downtime as possible. But when our workforces are cut and our sites are already limited in the way that they can operate, uptime becomes even more critical, and the impact of something that would produce downtime is even more costly. And of course, looking ahead to a post-lockdown situation where we're moving back into the workplace and back onto site in sort of a normal working environment, the ongoing costs of the loss of revenue will be that companies will have to become more lean and therefore need to cut costs. So as I've thought through these implications for companies, it's really been helpful for me to think about what I want. I definitely want to know what's going on. If I can look at some information that allows me to know what problems exist and make decisions based on information, that's super useful. So knowing is really important to me. The next thing I want to do is to save money, of course, but even before that, save time. It's really troubling to me not to have the same capability to intervene as normal. So in the new normal, where it's harder to intervene, I want to be able to have my team be as efficient as possible, and that means saving time and doing things based on priorities that are driven by data and information. And then finally, of course, I want to act. That's harder when there are fewer workers and when those workers don't have the same access that they had before. but I want to be able to act from a presence of information. So these things that I realized I really want as someone who's trying to operate a business and build technology solutions and deploy technology solutions are going to serve as the outline for the rest of this talk. I want to know, I want to save, and I want to act. And I think that remote monitoring is in some way, shape, or form an answer that provides us the capability to know, to save, and to act. So starting with this idea of knowing. What does it mean and what do you need in order to be able to know what's happening with your assets in an industrial setting? Well, of course, the promise of the industrial Internet of Things is to instrument up the assets or the things that you have to deal with. And in this illustration of an industrial setting, it's easy to think that there are many, many things. If you take any one of these asset categories, and the two that I'll be talking about as examples today are steam traps and motors or rotating machinery. Even a modest size manufacturing plant might have hundreds to thousands of steam traps and a similar number or even more, twice the number of motors and rotating machinery. So that's a huge number of assets. So if I'm going to deploy an Internet of Things solution to help me to monitor those assets remotely, I'm going to need lots of sensors. I also want those sensors to provide data continuously. It really doesn't do me much good if a motor fails. It's going to lead to downtime if I don't know about it until tomorrow or even 3 hours from now. So I would really like the data that comes from these sensors to flow continuously. And I definitely want the data to matter. What I mean by that is there are some sensors that measure things that are not actually truly useful to getting at the heart of the problem that I care about. And again, the things that I'd like to know relate to actions that I can take to intervene when there are problems. So things like uptime and the impact of a certain type of failure on the actions that my plant normally would take. And then finally, I think it's critically important that that data actually gets to me. It does no good if it sits in some repository that's hard to access. And that's become even more, I've had more awareness of that in this post-COVID-19 world when the people who are working on our teams are not in the places where they usually are, which means that information needs to flow to them, which makes a remote monitoring solution even more important. So putting these together and thinking about what is required in order to achieve remote monitoring, in order to get what we're thinking of as a truly pervasive remote monitoring solution, by which I mean a real visibility in almost real time across all the assets, it means I have to get to lots of sensors, and I can only do that if I don't have to spend tons of money to do the deployment. So a cost-effective deployment is critical. Maintenance-free devices are also critical. It's just infeasible to put tens of thousands of devices out there that require human intervention, even at the pace of, every few years per device. If you multiply that by a large number of devices, you're quickly spending as much time managing the monitoring devices as you were managing the assets in the first place. And of course, we already talked about how the need for continuous data streams and end-to-end solutions that provide that useful data all the way to the end users of the data are critical in order to enable the system to provide what you really want it to provide, which is actionable information. So hopefully this paves the stage for the requirements for achieving a solution that allows remote monitoring to be truly useful in terms of knowing what you want to know about your assets. This slide shows the way Everactive has tried to provide that pervasive solution and how the Everactive technology can enable those requirements. Low cost, easy deployments without maintenance required, with continuous data that flows end to end all the way to the end user. And the solution consists of a few key items. First of all, wireless devices are placed right on the assets that we need to monitor and use sensors to monitor the sources of raw information that are critical to getting at those actionable insights. And then that data flows end to end all the way to the cloud through a wireless network, through gateways, and then through a back-end network, all the way into the cloud, from where, of course, these days it becomes more straightforward to pass that information seamlessly on to the end users who need to make decisions and share the information to have actions. the key here is that the wireless devices that Everactive has developed to put on the assets don't need batteries. They're self-powered. They get power from their environment by harvesting energy and then storing that energy. And I'll talk about that a little bit more in the next couple of slides. But that is really critical in achieving those first couple of requirements for a pervasive remote monitoring system. Specifically, it makes the deployments very low cost, and it eliminates the need for maintenance of these devices because you don't need to go back to them to replace batteries later. So they'll pretty much operate for the lifetime of the assets that they're monitoring. So really, if you're thinking about achieving a truly pervasive remote monitoring solution on a scale of your entire industrial site across thousands and thousands of assets, the only really feasible solution at that scale is a batteryless solution, and that's the key behind Everactive's technology. So just in case some of you are not familiar about the concept of self-powered operation, I wanted to talk about what it takes to get rid of batteries and replace these batteries with a no battery solution. So I like to think about the flow of energy in a self-powered system as being analogous to a tank of water that's harvesting, instead of power, in this analogy, water, maybe from rain or a natural source, where that water is available but not in a form that's easily usable. So what do you do with it? Well, you store it. You fill up a tank, you save it for later use, and you can condition it or regulate it to consume it in the way that you need. And this analogy works really well. This is exactly how we build self-powered wireless sensors at Everactive. We harvest power from some available source in the environment, such as photovoltaics, which harvest from light, thermoelectric generators that harvest from a temperature difference. We can harvest from vibration, from RF energy, or from electromagnetic energy as well. And then we take that intermittent source of energy and we harvest power from it and then store it in a capacitor on the node so that we can live through brownout periods or blackout periods in the harvested energy source. And then we smartly consume it. Specifically, if the amount of power that we're harvesting is larger than the amount of power we want to use, well, that's a nice, easy scenario. It means we can work away doing whatever we want, and any extra power that we're harvesting we can store for later use. On the other hand, and unfortunately this can happen frequently, if the harvested power is less than the amount of power we want to consume in the circuits that do the useful work, then we of course have to reduce what we're doing and cut back on the amount of work that we're doing and rely a little bit on that stored energy. This requires a solution that's intelligent, that can track how much power is available, how much we're harvesting, how much stored energy there is, and that adjusts how much work it's doing and how the system behaves as a function of the power environment. And we've built a solution that does that and that manages the case where the harvested power is changing, but we can make intelligent decisions about how to operate. And the conclusion here is that we can build sensors that operate with no battery whatsoever in a reliable fashion by intelligently managing that power that's available. So specifically, I want to mention two example products because I'll use them as I point out some of the advantages of remote monitoring through the rest of the talk. Everactive's first batteryless product is called the STM system. It's for steam trap monitoring. You may not know what a steam trap is. I didn't know what it was a few years ago, but steam traps are used all over the place. Steam is a very reliable way to move energy around in a manufacturing setting or for heating and cooling applications or other applications. And when you distribute energy in the form of steam, and then you take energy back out of that steam, the steam converts back into water, which is called condensate, of course, and you need to get that water out of the steam pipes. So a steam trap is simply a valve that allows condensate to move out of the steam system while keeping steam in the steam system. And a decent-sized plant with a boiler that distributes steam around the plant can have many hundreds or thousands of these steam traps. And when they fail, they can cause big problems, and we'll get into some of what those problems are in the form of some of the examples later on. Because there's so many of these steam traps, we had a well-respected leader of the maintenance program at an industrial site say, I do not use battery-powered devices of any kind because I'm unwilling to trade one maintenance event for another. The existing maintenance event, of course, is manually investigating the performance or the state of a steam trap And if you put a battery-powered device on that steam trap, then now you have to manually maintain that battery-powered device, and you're not really better off. The second product example that I wanted to mention is we call machine health monitoring, and it's a monitor that looks at the vibration and other signatures related to rotating machinery, electric motors, and some of the driven equipment that they drive. So this solution also is dealing with devices that power different pieces of equipment in the plant, and these rotating machines, of course, serve many functions. And monitoring them remotely allows us to reduce costs in the case of the steam traps and in the case of the machine health monitoring. Costs in the form of downtime. Of course, we want to keep the manufacturing operation up and running as much as possible. Reduce costs in the form of maintenance. Reduce costs also in terms of energy and safety. We'll talk about some of these coming up. But right now, this section of the talk, I want to know what's going on with my assets. And one huge advantage of these batteryless sensors is that since they can go on every single asset in this class, I can know exactly what's going on with them. In the case of the steam trap, if it fails open and is allowing steam to blow through that trap, that steam is basically pouring down the drain and it's costing a significant amount of money because, of course, it takes money to provide the energy that's used to produce the steam in the first place. This is like running your air conditioner at your house, heavy duty, on as hard as it can be with the windows open. It's just costly for no reason. Also, these steam traps can fail cold, which means they close and back up condensate into the steam system, and that can cause both downtime or, in the worst case, serious safety hazards like explosions. In the case of machine health monitoring, remote monitoring of every single asset in the plant allows me to see what's going on with those motors in terms of vibration increasing or changes in the frequency profile of those devices. These are just a few of the things that we can monitor with our sensors, and that allows intelligent decisions about understanding and knowing which motors are trending toward failure or what kinds of problems might be coming up in the case of the motors or whether failures have actually occurred, which of course leads to the ability to take action. So remote monitoring really allows you to know what's going on with your assets. You can know what's happening in places where you are not, which of course supports a remote workforce, which is part of the new normal with COVID-19 response. It also allows you to know all the time and anywhere because the data streams are continuous and they flow end to end all the way to the people who need to take action. So that allows the right people to know right away. And it really de-risks operation of the assets because you can make decisions based on data and allocate resources and set priorities based on data. So the second thing that I said I'd love to do or to be able to have in the new normal situation is the ability to save. Of course, I think COVID-19 is pointing out or forcing companies to become more lean, as I said earlier. And it really points to the fact that saving both money, but also maybe more importantly, time and efficiency of your human resources becomes really compelling. But there are other forms of savings as well. And the benefit of remote monitoring is that it provides savings almost for free, or maybe even better than for free. So in the case of Everactive steam trap monitoring product, there are huge advantages in terms of saving to monitoring these devices. In fact, the industry estimates that across the whole world in terms of steam distribution, over $50 billion are lost in energy costs and downtime just because of failures in steam traps. And that leads to huge losses that have environmental implications, including over 300 billion gallons of water waste and 300 million metric tons of carbon dioxide emissions. So these are really meaningful impacts on the environment. In terms of just the money, for a single example of outfitting a facility with 1,000 steam traps, the product allows you to pay for itself in a period of just 3 months. In other words, the full yearly cost of the product is recouped in terms of energy savings just from steam going through open blow-through traps in about 3 months. which is a really significant hard ROI. And one way to put it is that it actually is costing the plant money not to monitor these devices. So the ability to do remote monitoring saves pretty much for free. The savings are even more significant in the example of machine health monitoring. And the industry looks at numbers that attribute different savings to motors, but motor failure on average can lead to significant costs in terms of downtime. So if you are able to prevent those failures, there's a huge uptime savings that's independent of the horsepower of the motor. For larger, higher horsepower motors, there are additional savings available in terms of energy consumption, the reduction of energy loss by ensuring that motors are running more efficiently, and of course savings in terms of not having to do manual maintenance except when it's really required. This is basically reducing the cost of a manual inspection. So again, the ability to remotely monitor and to know what's going on with all of your assets has an intrinsic saving in terms of dollars and efficiency of your team. Of course, an unstated advantage here of these savings is that the human resources are freed up to spend their time on things that are more important. There are also significant returns in terms of the environment. Just looking at Everactive steam trap product, which we first put on the market in 2019 and deployed just over 1,200 steam trap devices in that year, just those devices in the first year of the product's life led to an estimated energy savings for our customers of $2.5 million and savings in carbon dioxide emissions equivalent to 7,300 passenger cars and over 89 Olympic pools full of water savings. So there are, as I mentioned, environmental savings that are truly significant that come for free from the kind of remote monitoring that allows you to know what's going on with your assets. Similarly, if you're looking at machine health monitors and allowing for just a 2% improvement in efficiency from the kinds of maintenance that you can do when you know what's going on with all of your assets, that leads to really substantial numbers in reductions of energy costs that depend on the horsepower of the motor and the number of motors you're looking at. So just to wrap up the idea of savings, savings occur in terms of hard return on investment and reduction of costs in terms of dollars, but also an advantage of the remote monitoring is that the data you're measuring from those assets proves out the savings and shows the ROI. So it makes it really easy to see that you are in fact getting the return on investment that you would expect. And of course, savings to your team come in the form of allowing you to send your team to do the acts that are most needed and to be most efficient. And when your workforce is reduced or limited in their ability to intervene, that becomes really important. And then the last thing I would mention, of course, are the environmental savings, which have a big impact as well. So the last thing that remote monitoring can allow you to do is to act. And I wanted to just circle back to that. I've talked about it a few times in the examples I've already given, but this slide just shows some snapshots of the data and the representations of the data that are available in the cloud from Everactive steam trap monitoring product and machine health monitoring product. And this information allows you to take action. For example, with the steam trap overview, it immediately guides you to exactly the traps that are failed, and it even sorts those traps that have failed in order based on what you're interested in. But for example, you can sort them based on the rate at which they're losing energy and costing you money, so that if you have more traps failed than you can reasonably go address at a single time, you're able to send your team to the traps where you're going to have the most ability to save. And similarly with motors, the data in the cloud allows you to zero in very quickly on the motors whose maintenance will have the most impact on reducing downtime or other metrics that you really care about. And just to give a couple of examples, this is just an example of thinking about what happens in a manual inspection scenario for steam traps, which is the typical case in the industry today. if you do an inspection in April and aren't planning to do your next inspection for another year, which is typical, then a failure that occurs a few months later will persist for a good chunk of the year potentially, and can cost a lot of money in steam and also the environmental impact, of course, of losing that steam. In contrast, having the information available to tell you when that failure occurs and allowing you to act immediately stops the waste, reduces the costs, and of course achieves the savings that you're hoping to achieve. There are other side benefits that we've started to uncover at Everactive of having all of this information. As one case study, one of our STM manufacturers or customers in the manufacturing sector had all of the steam traps in their plant covered with monitors, and they were, of course, accruing savings from identifying failures in the individual traps. But because they were correlating information across all of the traps and looking at information about the steam itself as it was distributed to the different devices, they were able to determine from the data that was available to them that one of the boilers was oversized, and they were able to make changes in the boilers that dramatically improved the efficiency of the overall system. So this is just a great anecdote that reveals how more data and remote monitoring and having those data streams flow all the way through an end-to-end system can unlock new insights that allow actions that are really meaningful. Everactive thinks that these remote monitoring benefits are really just available in many more places as well. And the technology platform that we've built is capable of harvesting energy from light, from indoor light, from thermal differences, from electromagnetic fields and RF fields, and from vibration. And the sensors are a suite that are available that allow us to monitor a lot of different assets. So I've described our products for steam traps and for motors, but those are readily extensible, and we're working on follow-on products that can go apply to many of the other assets that I am mentioning on this slide, and even more. So the advantage of this, of course, is that it allows you to act wisely across all of the different assets that you might be in charge of monitoring and operating. It allows you to know what's wrong and what to do so that you can respond to a crisis situation efficiently, but also with a remote workforce, it allows you to make prioritization and allocate resources based on information, so that if there's too much to do, you can decide the things that are important to do now and put off the things that can be scheduled for a future time, which allows you, of course, to act in a way that makes the most of your team. And I think your team is your most valuable resource. So if you can use it most efficiently, then it's highly advantageous. So just to conclude the talk part of this seminar, we hope that this has helped to highlight the value of remote monitoring, particularly in a time where we're responding to this COVID-19 crisis and having to get used to a new normal where our teams are limited in the way that they can access the assets that they are used to accessing, and also moving toward a time where lean is going to be the new operating regime. Remote monitoring allows you to know what's happening where you are not, to save money, your team's time and resources, and then to make use of that data and that knowledge to act efficiently and wisely. So thank you for your time and attention. My contact information is here at the bottom, and so is Brian's. And now we're going to take questions through the written Q&A panel. So please submit your questions, and we'd be happy to answer them.
All right. Ben, can you hear me?
I can.
All right. So we had a handful of questions come through already. Some more technical, some higher level. We'll start with the more technical questions, and then we can work our way up. First question that comes in: are your systems waterproof and chemical resistant? Daily washdowns in food plants is the consideration there for this question.
Yeah, that's a great question. And yes, our first two products are, and all of our products are industrially hardened. They're actually rated for hazardous locations. So they're C1, D2 rated, and they're IP66 and IP67 rated. which allows us to put them in, and actually we have customers for the Steam Trap product in the food and beverage industry where, yeah, the products currently experience these daily washdowns, which can be pretty rough. So, of course, it's important to have the physical sensors be robust to the industrial environment where they operate.
Thanks, Ben. Next question, how does the motor sensor harvest power? Is it from the motor casing temperature difference only?
Yeah, that's a great question. So the default source of power for the MHM product is a thermal difference between the motor casing and the air. But that product, the MHM product, also supports indoor light harvesting, electromagnetic harvesting, and RF harvesting. So we can use any of those modalities. And the reason we support all those different options is that not all motors have a good harvesting environment for any one modality. We've found that light and thermal differences are one or the other are useful ways to harvest for almost all motors, but maybe not every motor. Electromagnetic fields work really well for certain motor models and not very well for others. So there's a variety of options there for what to harvest from, with the thermal gradient between the chassis and the air and indoor light being the most common.
All right.
And I should maybe mention that that the real secret sauce in the technical solution that Everactive has built is custom electronics that are much, much lower power than the electronics that you can buy off the shelf. So we are able to make use of far smaller amounts of harvestable power, which is why we can get away with operating continuously from these harvested modalities.
Great. Next question, Ben. Another technical question. What wireless protocol does the Everactive system use to communicate sensor data?
Yeah, that's a great question. So we use two different radios in the batteryless devices. One is a custom always-on receiver that is listening continuously. It's never off, so it's 100% duty cycled. Unlike a lot of the commercial radios that achieve low power by being off most of the time, this custom receiver that we've built listens continuously, and when it's on, its active power is less than a microwatt, which is exactly why it can stay on all the time. And that always-on receiver allows each of these batteryless devices to be in very low latency contact with the gateway. So the gateway can issue a command to either an individual sensor or to a set of sensors, and all of those sensors hear it and are able to respond within just a millisecond or so because the receivers are always on. Now, once they receive that command and want to communicate a payload of data back to the gateway, they use a standard sub-gigahertz 802.15.4G protocol radio.
All right. Thanks, Ben. A couple more technical questions here. How much data can be transmitted by using your system? Can you elaborate?
Yeah, that's a great question. So I just mentioned the sort of the exchange of information, the way it occurs. The gateway will typically initiate a request for information from sensors. That can happen on a schedule. The default is that all of the sensors report in every 30 seconds or 60 seconds. But the sensors can also initiate communication if they sense some sort of event that is of interest. Then they can, we call it an alarm event, they can send us a signal to the gateway. So how much data can they send? Well, that is really only limited by what you decide you want to send. Of course, the default is that we're not sending reams and reams of raw data. In fact, one of the advantages of low power electronics, I can give an example for the machine health monitor, is that we can do information extraction right on the batteryless device. So we actually acquire 3 degrees of accelerometry data on the motor for an extended period of time, and then compute locally on the batteryless device how much energy is in band for that vibration, and also take FFTs and compute the peaks that see the most energy and the frequency content. And then we can communicate back just the energy and the value of those frequency peaks. Of course, we can also send the raw data, but that takes more power. So we, again, use a smart solution that makes decisions about when to send the raw data, when energy is available, or when it's really important to send it, for example, because a particular type of event has occurred. But in the normal case, we're extracting key information locally on the node and then sending that information.
Thanks, Ben. So one last technical question that came in. How long can the capacitor keep the sensor running in the event of losing harvested energy sources?
Yeah, that's an excellent question. So the answer really depends on on whether or not you change your behavior. So in the case of the steam trap monitor, if we if we just have the steam trap monitoring device continue to do its normal operation unchanged, then it will continue to operate for a good part of a day. If you put it into a lower power state and try everything you can to save power, it can last longer on the energy stored in the capacitor. Of course, in a different application where you anticipated that you would have longer periods of time where you don't have energy, you could further engineer that solution by having larger amounts of capacitance to extend that time as needed. Great.
All right, Ben, next question we have, I'm going to actually synthesize this one. There's a few similar questions. The attendee writes, this looks like an idea to promote to operations and upper management. Do you still provide the product as a maintenance budget item and nearly no capital expense? There were other questions around the business model and the cost effectiveness of this. So maybe just a quick word on the model.
Sure. Yeah, so Everactive's business model for these solutions is to sell them as a monitoring subscription. So we basically sell a subscription, for example, in the case of the steam traps, as a per steam trap monitored per year. And that subscription is not an upfront CapEx cost. It's a yearly subscription, similar to what you would pay for software as a service. We like to call it insights as a service. The hardware comes for free. It's included in the subscription. And then the data from that self-powered hardware flows basically for the lifetime of the devices. So that's the business model. And yeah, we agree. We like to think that it is a solution that should be promoted to upper management. And because of the hard ROI and the hard savings that are exemplified in the case of the STM and the MHM products, we think it's a solution that hopefully will become widely adopted because it pays for itself very quickly.
All right, thanks, Ben. Moving a little higher level, longer term, what do you view as the quote-unquote killer app for this type of technology, or is it steam traps and motors?
Yeah, that's a great question. No, I don't think steam traps and motors are the killer app, although both I do believe are quite compelling for some of the reasons that we talked about today. It's a little hard to say what the killer app is writ large. I think the killer app for different industries and for different environments will vary. But the way I would put it is the killer app comes when you've got enough sensors on enough types of assets such that the data that you're pulling in allows you to have insights that are beyond the limits of any individual asset. So I mentioned the anecdote about understanding that your boiler was operating inefficiently because you're monitoring steam traps. I think that's just a hint of the kind of emergent information that might become available when we're putting an Internet of Things out into an environment like an industrial plant. To the extent that we have information from so many assets that information is starting to reveal underlying insights that are independent of any one asset.
Great, thanks, Ben. We had a couple questions around, this one's for the sales guy, our sales guys on the phone. What's the best way to get our hands on some of Everactive sensors to do a test run or otherwise deploy the solution?
Yeah, that's a great question. I think, you're looking at my email address and Brian's email address. You can definitely start with either of us and we'll put you in touch with our sales team. But we are actively deploying both of these products. In the case of Steam, it's, for sale right now. The MHM is going to be launched as a full product in Q2, end of Q2 this year. Delayed a little bit thanks to COVID-19, but it's already deployed in some beta pilots with customers. So we can get you going if you're interested.
Great, thanks, Ben. We'll end with one final question that seems appropriate to end with, given the topic. What's been COVID-19's impact on Everactive's business? How's the outlook?
Well, there's definitely been an impact. Obviously, along with all of you, we are not in our office spaces anymore. We're pretty much fully working from home and have been since actually several weeks before the lockdown orders were initiated. So that does have an impact. We're fortunately able to continue a lot of the activities and development that we were already doing, but of course it impedes some of the work that we do in our own labs, and there have been limitations to our ability to get into certain customer sites, understandably. We were initially surprised to find that the connections that we have with customers and the conversations we're having with customers have not slowed down. In fact, in a lot of cases, they've ramped up, perhaps partially explained by some of the things we're talking about in this webinar, the realization that, hey, I'm not on my site and I want to know what's going on there. And these kind of products enable that through the remote monitoring. So, our sales have slowed over the last month. I think, that is understandable as decision makers are having their attention pulled rightly to responses to COVID-19. But the interest in the products, again, have ramped up. So we're hopeful that the usefulness of these products will lead to those sales continuing forward as the decision makers are able to bring their attention back around to completing those sales. We're a startup with investors who back us, and those investors remain very committed to us. So we're going to be around for the long haul through this crisis. Thanks, Ben.
So that's actually all the time we have for today. Thank you, Ben, and to all the attendees on the phone, the Zoom webinar. Thank you for your time as well.